Chances are that by now you've become fairly good at plotting data and calculating slopes. For many of your math classes and lab reports up until now, the slope was the answer. Welcome to a brand new world, future fellow physicists. Let's go a bit deeper into analyzing data and comparing models and trend lines. Models are the equations that describe physical situations. These are the equations that you've come to know and love while taking your physics classes. For example, E equals mc squared is a model. V equals v naught plus a times t is also a model. Trend lines are the fits that we add to a graph. For most introductory classes, the model and the trend line follow each other closely. Sometimes, though, we have to play around with the equations to match the trend lines. If you go into Excel, Google Sheets, or another spreadsheet program, you can usually add trend lines to the graphs you produce. In Excel, there are several options. The most common form of trend line is the linear trend line. The equation for this trend line is the slope-intercept form, y equals mx plus b. The y represents the dependent variable, the m represents the slope, the x represents the independent variable, and b represents the y-intercept, where the graph crosses the y-axis at x equals 0. The trend line you pick should represent the model you are testing. Be careful here. Make sure you know which variable is which. For example, don't confuse the m for the slope with the m for the mass in the experiment that you're doing. Also be careful when you plot the value of the x position on the y-axis. Let's imagine hanging a spring from a support, then adding some masses to it. We measure out each mass, calculate its weight, then we measure the stretch of the spring. The model for this is Hooke's law, F equals k delta y. We could also put a mass on the spring and then measure the period of its oscillations. The model for this is T equals 2 pi times the square root of the mass over the spring constant. In each case, we plot out our findings on a graph. Let's look at the force and the mass. Notice where the variables are. Since we picked the mass that caused the force, we placed the force on the independent axis. The displacement is the result that we measured, so it went on the dependent axis. The data turns out to look fairly linear, so we added linear trend line in the form y equals mx plus b. This looks like a linear equation, but notice that the displacement is on the y-axis and the force is on the x-axis. We place these in the slope-intercept form in the right spots. Notice that m is the slope, not the mass. The intercept doesn't show up explicitly in our model. This means that it should be close to 0. The fact that it isn't quite there tells us that we might need to tweak our model. Now we're ready to do some fitting. We start out with our modified Hooke's law, delta y equals 1 over k times the force. We compare this with our trend line equation, y equals mx plus b. We fit the model and trend line together, getting delta y equals the slope times the force plus b. Since the slope is 1 over the spring constant, we get delta y equals 1 over k times f plus b. This leads us to the result that the slope is equal to 1 over k. Solving for the spring constant gives us k equals 1 over the slope equals 1 over 0.0414 meters per Newton. Putting it into our calculator and flipping the units into the numerator gives us the final result. K equals 24.15 newtons per meter. This likely has too many significant digits, but we can fix that later. We can now see that the slope in this situation wasn't the answer that we were looking for. Many students do this lab and find that their slope of 0.414 meters per Newton is 99.8% off of the answer of 25.0 newtons per meter that they were expecting. They just report this, not realizing that the units of the slope aren't correct. They also don't ask for assistance for this large error. Don't be that student. Always check your model to make sure it matches your trend line. Also make sure that your results have the right units. Ask for help if you have a large percent error. We'll look at more complicated models and trend lines in the next video.